Hello students, in the previous lecture I was discussing about the computational models in embedded system. I discussed till state machine model, and then here I discussed till yes, state machine model, and then I'll be discussing about sequential program model. So in the sequential programming model, sequential execution of program takes place. Here the program instructions are iterated and executed conditionally, and the data gets transformed through a series of operations. So finite state machine a model are good choice for sequential programming model. Another important tool that is used for modeling sequential program is flowchart. You can see the previous example only, that is the seat belt and ignition example that I used, that I took, and I designed it using the state machine model. I'll be taking the same example. So here it is the flow chart, that is if ignition key is on, then wait for 10 seconds and then again see whether the ignition key is on or not. If it is not on, then it is N. But if the ignition key is still on after 10 seconds, then it will check whether the seat belt is on or not. If the seat belt is on, yes, then it will N. Or if the seat belt is not on, then it will set timer for 5 seconds and it will start the alarm again. Ignition key on, it will check ignition key on or not. If it is yes, then it will check seat belt on or not. If seat belt is not on, then timer will expire, then it will check whether timer expired or not. If the timer is not expired, if the timer is expired, yes, then stop alarm and then end. So this is the flow chart for the previous example only. So using this flow chart model or using the finite state machine model, here this is the programming for this is the programming for sequential program model. So this is how you can we can make the programming for sequential program model using the finite state machine model or flow chart. Now next is the concurrent or communicating process model. So here what happens, sequential execution, as we know, sequential execution leads to poor processor utilization, because when the task involves input output waiting, sleeping for specified duration, etc. But if the task is split into multiple subtasks, it is possible to tackle the CPU usage effectively. When the subtask under execution goes to a wait or sleep mode by switching the task execution. So we can split the task into timer task for waiting 10 seconds, task for checking the ignition key status, task for checking the seat belt status, etc. So here we have taken the previous example only, and we have splitted the task into various subtasks like wait timer check, ignition key status monitor task, alarm timer task, alarm control task, ignition seatbelt status monitor task. So this is how in sequential execution, in the previous model, in the sequential execution, it leads to a single sequential execution of tasks, whereas in this model, in concurrent or communicating model, what happens, the task is split into multiple subtasks. So this was about the communicating model, and the last model that is remaining is the object oriented model. Last model is the object oriented model. So the object oriented model, it is an object based model for modeling system requirements. It disseminates a complex software requirement into simple well defined pieces called objects. Here the object is an entity which is used for representing or modeling a particular piece of system, and the class is an abstract description of a set of objects, and it can be considered as a blueprint of an object. So this was all about the modeling. So here in the lectures I have very briefly discussed about this lectures, whereas the notes that I have provided you about the chapter notes from the book Shibu KV, go through the chapters like chapter 2, chapter 2, then 7, 10, and then chapter 3. Go through these chapters. The chapter that I've discussed now, that is hardware software code design, is the chapter 7. You'll get all the detailed notes there. So I'm ending this class here. Thank you.